about the nucleus, means nuclei contains of protons and neutrons. Both protons and neutrons are called as nucleons, and electrons are revolving around the nucleus in a path. And the protons and neutron number of protons is considered as the atomic number of the nucleus atom, and as well as the number of nucleons, means the number of protons and neutrons are present inside the nuclei is considered as its mass number, atomic mass number. So here is that by taking that, the notation which can be the elements, means the chemical notations can be given as like X, A, Z. X is the chemical compound, and at the same time A be the atomic number and Z be the atomic mass, A be the atomic number, atomic mass number, and Z be the atomic mass number. So in that case of here we are going to discuss about atomic number Z, and A be the atomic mass number. So it is the Z means atomic number, A be the atomic mass number. In that case of the notations, chemical bond notations can be done like this. So here the different elements are having the different properties by the number of protons are changing and number of neutrons are different in the different elements. By taking that, by changing the numbers of that neutrons or protons inside the nuclei will give the different properties. In that case of we can distinguish that elements like the isotopes, isobars, isotones, and about that by their physical existence, means about their characteristics we can distinguish into the several types. In that case the first one is isotopes. Isotopes means whenever the chemical compounds are having that the atomic number is same, the atomic number is same, but with the different atomic mass number. Atomic mass number will be the different. Means here we can have some of the examples. The atoms of the elements which having the same atomic number, but different atomic weights, means different mass number. Due to that, here in the atom, in the nuclei, in the atom, the number of protons in the nuclei and electrons revolving around the nuclei will be the same. But in case of different numbers of neutrons are present inside the nucleus, so that's why here the atomic numbers will be the different, because of we know that the atomic number of atomic mass number means the number of protons and neutrons is considered as atomic mass number. So that here the different neutron numbers are having inside the nucleus, so that's why the mass number will be different. In that case you have the elements having the same number of protons and electrons, but different neutron numbers, so that's why the atomic mass number is different. So in that case of atomic mass numbers, these are the 1H1 and 1H2 and 1H3 is the isotopes of hydrogen. Means here 1H1 is a hydrogen, deuterium, tritium. Because of here the number of protons is 1 in the hydrogen atom, but different neutron numbers. Here is the only 0 atomic number, here is the neutron number 1, here is the neutron number 2 neutrons are there. So that's why in the tritium will be the radioactive material, means it is in the active state, always will be in the active state. There is no, we can't get naturally, it is a artificial, we can develop in the laboratory. So in the several examples of helium, carbon, oxygen also there. Here 2He3, 2He4, 2He6, means here which is having the proton number of protons are 2 and 1 is the neutron. Protons are 2, 1 is the neutrons in the helium, and in this case of 2He4 the 2 protons and 2 neutrons, different number of neutrons are there. In that case of 2He6 there is a 2 protons and 4 neutrons. So these are the isotopes of a helium atom. In case of carbon, there is a 6C10, 6C11, 6C12, 6C13, 6C14. These are the carbon atoms isotopes. Here 6 is the protons and the remaining 4 be the neutrons. Here the 6 be the proton number is same in that case of all the atoms. So that is 6 is in this case of 611 the atoms are 6. In that case protons are 6. Here 5 be the neutrons. Here 6 is the proton, 6 be the neutron. 6 is the proton and 7 be the neutron number. Here 8 be the neutron number, 6 be the proton number. So these are the isotopes of a carbon atom. In case of oxygen, the 8 be the protons number and 8 is the neutron number. It is a stable oxygen atom. And in this case of here 6C14 be the radioactive material, means which is in the excited state. Here 8O17 means here having the 8 is the 8 be the protons number and 9 be the neutrons. Here 8 be the protons and 10 be the neutrons. It is the isotopes of oxygen. Means in this case of all the atoms, the proton number are same. In the case of hydrogen, helium, carbon, oxygen, several more are there. In that case of total atoms, only the proton number is same. But due to the different number of neutrons, they behave with the different characteristics. These total atoms we can get in the periodic table at the same place. In that case of same place in a periodic table, we can see this. So that due to the change of neutrons, the radioactive substances means they move into the excited state by the increasing the neutrons count. So the number of neutrons are increases, then they will move into the excited state. Here the 1H3, 2He6 and 6C14, O8O18, those are the, we can't get it in naturally, that will be the laboratory, that artificially we can develop that, the elements. This is about isotopes. Means once again, in that isotopes of materials, only the neutron numbers are different. Means same atomic number and same atomic number but different atomic weights are called as isotopes elements. In that case of due to the change of different number of neutrons, the mass number will be changes, different, it will be different. This is about isotopes. The next one is isobars. In that case of isobars, it is in opposite. Means in that case of atomic mass number is same, but different atomic number. Means Z will be different, A be the same. Z will be the different. Means like here elements having the different number of protons, electrons and as well as neutrons also. Means one element is having different protons, two elements are having the different protons, neutrons and electrons. But their nucleons count is in that is same. Here the some of the examples we are going to see is the hydrogen, helium, 1He3, 2He3. The nucleon count is same in these two elements, but the number of protons are different. That is, here is the number of protons is 1, here is the number of protons are 2, but the total number of nucleons are same. Means elements having the different number of protons here and here if we compare with the both, different number of protons are there, electrons are there and different number of neutrons also there. Here the one of the proton, here the two neutrons. Here 2 is the protons and 1 is the neutron. Means neutrons number is different, protons number is different, but the total nucleons number is in the same. The total number of nucleons are the same. So that's why 1He3 to 1H3 and 2He3. These are the isobars. And if we come for the lithium and beryllium, lithium atomic number is 3, beryllium atomic number is 4. Means the number of protons are present inside the nuclei will be in lithium is 3 and beryllium is 4. But in case of the nucleons are same, in the case of nucleons are same, that is 7 and 7. When the 3 protons are present inside the nuclei, then the remaining 4 are neutrons. 4 neutrons and 3 be the protons. So 3 protons and 4 neutrons in the lithium, and at the same time beryllium, in that case of 4 protons and remaining 3 will be the neutrons. Means the protons are different, different number of protons are there and number of neutrons are different. So that's why, but they 3 plus 4, 7 and here is also total 7. Means the nucleus, number of nucleons present inside the nuclei is same. So that atomic mass number is same, but their atomic number is different. For the different materials are having the same atomic mass numbers is considered as isobars. Means the atoms which having that, the elements are having that same atomic mass number but different atomic number for the different elements, but the different elements are having the same mass number due to the different protons and neutrons present inside the nuclei, which is balanced by that. If in case of 3 protons are there, then 4 neutrons are present inside them. If in case of 3 neutrons are there, 4 protons are present inside the nuclei. So that the lithium and beryllium will be the isobars, and here arsenic and at the same time calcium. So in that case of here 1840 means the number of protons will be the 18 and the remaining neutrons are 22. Here the protons, number of protons are 20 and neutrons also 20, means a different number of protons are there and a different number of neutrons also there. So that the same atomic mass number but a different atomic number, this both is considered as, so this is also isobars. Isobars. And another one is here 11Na22 is sodium and neon. Here 11Na22 number of protons present inside the nuclei is 11 and another neutrons is also 11. In that case of neon, the protons count is 10 and neutrons are 12. The different mass number due to that change of neutrons and protons, different number of protons and neutrons are present inside the nuclei, but their protons are different. Atomic mass numbers means the number of nucleons present inside the nuclei is same. So this type of which is the elements are having the different protons and different neutrons and different electrons, even though their atomic means the number of nucleons present inside the nuclei means that mass number is same, is considered as a isobars. These elements can be shown in the periodic table at different places. These different isobars can appear in the periodic table at a different places. So that these are about isobars. Once again, the isotopes means the elements are having the same atomic number but a different atomic mass number due to the different number of neutrons present inside the nucleus is considered as isotopes. Here, according to the isobar, the elements which are having the different number of protons, different number of neutrons, different number of electrons present inside the different protons and neutrons present inside the nuclei, even though their nucleons, the total number of nucleons are in the same, means the atomic mass number is same but the atomic number will be different. That elements considered as those are the isobars. The next one is isotones. Isotones means the same number of neutrons present inside the nuclei, that elements are considered as isotones. Means here the atoms calcium and potassium both are having that same number of neutrons present inside the nuclei. Because of, if we take the calcium, in that case of 20 is the protons and 40 be the atomic mass number, by subtracting the atomic number from the atomic mass number, 40 minus 20, then we can get the 20 neutrons present inside the nuclei. And as well as if we take the potassium, then in that potassium also 39 minus 19. If we take the 39 minus 19, there is a 20 neutrons present inside the nuclei, means the number of protons are same in the two different elements. Here is the two different elements are there. Here calcium and potassium both are different, but their atomic mass numbers are different, atomic numbers are different, but both are having the same number of neutrons present inside the nuclei. So that the calcium having the 20 neutrons and potassium is also having the 20 neutrons. In case of copper and zinc, hydrogen and helium, here is also in case of copper and zinc, if we note that the number of protons inside the nuclei is 29, means in case of copper that is 63 minus 29, we can say that is 34. Next, that zinc, if we take the zinc, then 64 minus 30, then also 34, means the number of neutrons present inside the nuclei is same in both copper and zinc, but which is having the different atomic number is there, different atomic mass number is there. Even though they are the same, copper and zinc and calcium and potassium, hydrogen, helium, here oxygen, copper and chlorine and potassium, these elements are having that different atomic number, different atomic mass number, even though they are having that same number of neutrons present inside the nuclei. So that we can say in this atomic number Z and mass number are different, but the value of A minus Z, that means the number of neutrons, is same. So that this type of elements can be considered as isotones. Isotones means the elements which are having same number of neutrons in the nuclei is considered as isotones. Here is some of the examples: calcium and potassium, copper and zinc, hydrogen, helium, oxygen, chlorine, oxygen, carbon, and chlorine and potassium. Those are the some of the examples about the isotones. The next one is the isomers. In that case of isomers, which is having the different nuclear energy, which is having that the nucleus are same atomic number and same mass number also, same atomic number, same mass number also, but different from one another. Like if in case of strontium is there, that will emit the gamma radiation whenever it is exposed, and it will emit the gamma radiation, and its with the half life period is 2.8 hours. So in that case of, but different from one another in their internal structure and the nuclear energy, in their nuclear energy state. In the case of nuclear energy state, the most of the explosives can be used as uranium. That uranium X2 is also having a 92U234 UX2, and uranium Z, this is considered as uranium Z. Uranium Z. This is the uranium X2 and this is the uranium Z. Uranium Z also having the same atomic number, mass number and same atomic number. Even though they are having the different nuclear energy states and both are the internal structure is also different. So that this type of materials which are having the same mass number, even the same atomic mass number, same atomic number, but their internal structure and their nuclear energy states are different, the type of elements can be considered as isomers. Isomers. These are the by changing the its number of, by different number of neutrons and by different number of protons, the nucleus can be used in artificially developed in this type of uranium type of materials can be used in the explosives mostly by developing in a artificially in a laboratory. Then we can find out with different isotopes, isobars, isotones and isomers.